Hi, I'm Kara, and I'm here to walk you through chemistry. So, before we begin a topic that most people run away from, let's discuss why it's important. Think about your everyday life. You eat food, you brush your teeth, you play sports, you play music, you have temperature in your house, you have some electricity in your house. All of these have forms of chemistry with them. So, we're going to talk about the building blocks of chemistry and how we can relate it to our everyday big picture. This course is designed so that by the end you have a positive outlook on chemistry and can use it to think critically about your everyday life. It's literally a part of you as you are made up of it. So I hope that you enjoy chemistry as much as I do. And with that, let's get started with our first topic, which is atoms. Atomic theory has been formed over hundreds of years, and it's how we study chemistry today. You may have heard of the term theory before. Many of us use it in the terms of a hypothesis, where we say, if I steal my sister's phone charger, then she will be angry. And while that's true, that's not how we actually scientifically talk about theories. See, a theory in science is much more complicated than just a guess. It's actually a bunch of well-tested ideas that help to explain our observations of the everyday. Atoms are the smallest part of matter, and matter makes up all the stuff around us. Take, for example, a pencil. If I cut up this pencil into the smallest parts that I possibly could, even if I had superhuman vision with the best cutting edge technology, no pun intended, I still wouldn't be able to forever continue cutting it. At some point, I would have the smallest part of that pencil, and that smallest part is what we call an atom. Atoms are made up of three subparts that we call subatomic particles. The first of these are protons, which in an atom defines what we're looking at. Like you have a fingerprint that defines who you are, atoms have protons that define who they are. The first one, protons, are positively charged particles that hang out in the nucleus. The next subatomic particle are neutrons, which, like protons, hang out in the nucleus, but they have a neutral charge. And lastly, we have electrons, which hang around the nucleus in the electron cloud and are much smaller than protons and neutrons. Electrons are also negative, which is important when we're talking about the overall charge of an atom. But we'll get to charges in the next lesson. All of our pure substances, or the smallest parts of things that we can have, are found on the periodic table. Each element on the periodic table have unique characteristics about it. It's organized by an element's atomic number, which is important because that's the same number as their protons. See, since protons define what atom we're working with, we decided to organize the entire periodic table by it. Other things you can find in an element's box would be its chemical symbol and atomic mass. As for the symbol, the older the element is, the more it tends to have kind of a weird symbol with it that you wouldn't think would go with its name. For example, iron is Fe and mercury is Hg. Those don't really seem to go with each other. However, we have to keep in mind that this was made through hundreds of years, including at a time where people spoke Latin, which isn't even a language that's spoken anymore. So if you see kind of a weird symbol going on, that's probably why. As for the atomic mass, that is everything that can be found in the nucleus, which we talked about earlier was the neutrons and the protons. If you take the atomic mass and subtract the atomic number from it, you will end up with the total number of neutrons in an atom. So that solves how we find protons and neutrons. How do we find the number of electrons, though? Lucky for us, everything on the periodic table is neutral, which means it has no charges to it. We'll talk about later on how we can get positive or more negative charges in atoms, but for right now, we're going to say everything is neutral, which is great for us because that means that if we have neutral atoms, we have the same number of positive and negative parts to it. And we saw that protons are positive, electrons are negative, so they have to equal each other to create that neutral atom. Here are some acronyms to help us out. A equals P equals E. Atomic number equals protons equals electrons, otherwise known as our ape equation. Another one is M minus A equals N. This is mass minus atomic number equals neutron. So that's it for today's lesson. I hope that you enjoyed your first chemistry lesson. Let's go, you did it. If you want some extra help with practice problems, click on the next video and I go through a couple of practice problems for you. Other than that, I will see you in the next lesson. Have a good day. Bye.